This example of building an at-risk model will follow Example 2 in Chapter 1 of the textbook or the handout that's posted on Canvas. So what we're going to do is simulate a profit model for a business. And so the elements in this profit model are the unit sales, the price, and a variable cost. And variable cost is a percentage of revenue. And then there's also a fixed cost. So for sales, we're going to assume that the average level of sales are 10. And we're going to assume that the mean of price is 50 and the standard deviation of price is 10. And sales is going to have a probability distribution called a Poisson distribution, and price has a distribution called a log normal distribution. Variable cost as a percentage of sales is going to be between 0 and 1 because it's a percentage, and this is going to be modeled with a beta distribution. The 2 and 3 in this case aren't the mean and standard deviation of the distribution, they're just parameters that define the shape. So what we'll do is define distributions and at-risk for these three variables. So we would go up here to distribution and define. And now we see a list of distributions. And so we're trying to find the Poisson distribution. And what we would do in terms of Poisson, we can either click all or discrete, but let's click all. And we get a list of all the distributions and at risk. We can find Poisson alphabetically. Right here. And so we'll highlight Poisson and click Select Distribution. Now, the mean is the only parameter needed to define the distribution, and it's actually right here. This is a small Greek letter lambda. If you mouse over it, it says that's the expected value of the distribution, or also the mean. And so if we click in this box, what we'd like to do is typically use cell references to define distributions. And so if we click on this little red arrow, it says that it'll allow us a reference as an Excel range or formula. So let's click on that. And then it'll select an Excel range, and it's just one cell. So now that's C2. If you click back in there, it'll show you that there's a reference to C2. If you go over here, it'll show that the mean of the distribution is 10. And you can see that these are the possible values in the Poisson distribution. 0 is a possible value, all the way up to about 20, although technically they actually go higher than that. So we'll click OK. And now notice it has risk Poisson as a formula in this cell. Now, mine turned green, and this is a setting. Blue. Your cell may not turn blue. If you go to Settings, if you go to Preferences and Color Cells Preferences, if you want to have colored cells for inputs, an input is a distribution, an output we'll discuss, those are the main two things we'll have. You can change those to whatever colors you'd like. They may have come up with just no color, but if you'd like to have them appear blue, it's kind of handy. You can change those there. Now for price, we'll use a log normal distribution. So we'll go back to distribution and define. And we'll find log normal. there's two versions of log normal, but we know the mean and the standard deviation. So you'll notice in here it says the parameters of this distribution are the actual mean and standard deviation. So that's the one we want. And then here we have the mean, which is 10. The standard deviation is 10. But again, we want to use cell references whenever possible. So we'll reference the mean from cell C3. And we'll reference the standard deviation from cell 10. And now we see the shape of the log normal distribution. It looks kind of like a normal distribution, but the log normal has a longer right-hand tail. And now the beta distribution for variable cost. Here are the two parameters for the beta distribution. We'll use cell references. And you can see that this distribution ranges from 0 to 1, and that's because it's a percentage. The mean is about 0.4, right around in here. All right, so now we just need to use some logic and build this profit formula. The revenue is going to be the sales times the price. The variable cost is a percentage of revenue, so that would simply be the revenue times this variable cost percentage. And then gross margin is an accounting term that means revenue minus variable cost. In the formula that's in the handout, you can see that the fixed costs here are 100. So gross margin minus fixed cost will give us the profit. Now, if everything in our business is at average levels, this business would have a profit of 200. But we know that these three cells are random variables. Sales is not always going to be 10. It could be higher or lower. Same with price, same with variable cost. So what we want to do is see a range of outputs for profit. So we'll click in the profit cell, and up here we'll define profit as an output. And it gives you the option to change the name if you want, but it will usually try to find a name that's reasonable based on your labels. And in my case, it turns the cell red, and if you go into the cell up here, you see that now it's an output, but it still has a formula in here. So now what we need to do is run the simulation so that we can see the results. Now, it's hard to envision, but what at-risk does when you run a simulation is it simulates many possible values for these random variables and then recalculates profit. So let's do this. We'll usually use 1,000 iterations, maybe 2,000. Let's try 2,000. And we'll set the settings. If we want to get the same result from our simulation, we can change that on the settings so that you can match this solution. And it will work for smaller examples, not all examples. But if we go to sampling, and we go down here to initial seed, let's use a fixed initial seed. And I always just use 21 because that's my favorite number. So if you set your initial seed to 21 and I set my initial seed to 21, we'll get something fairly close. Maybe even exactly the same for this small model. Won't be exactly the same when we get to larger models, but we'll be closer. So we'll click OK. Now I've got 2,000 iterations, and so now we would just hit Simulate and start simulation. All right, and so it's important to try to understand what at-risk just did. It gives us this distribution for profit. If we move the cursor to sales, here are all the values of sales that it simulated. So it simulated 2,000 different unit sales, 2,000 different prices, 2,000 different variable costs. It made them consistent with these distributions. And then when it did that, it recalculated profit 2,000 different times. And so what we see here is the mean profit is 201.30. That's pretty close to the amount 200 here that appears. But there's a whole wide range of values that profit could have, and this is important for the manager to understand. So we could ask some questions using this distribution. We could say, well, what is the probability that profit is greater than 0? And so we can look here, we see 0 is here. If we change this slider value to 0, we see that 6.8% of the time profit's negative. So that must mean that 93.2% of the time, all of these values over here, profit's greater than 0. Because 93.2 is 1 minus 6.8%. We could say, what is a 95% certainty interval for profit? Here's what that means. If we change now this middle percentage to 95 and hit enter, we see that there's a 95% chance that profit falls between negative 35 and positive 572. So we know that there's some extreme values, but this gives us a pretty good idea of a range where profit's likely to fall. And it's a wide range. Now let's answer another question. 10% of values for profit fall above what number? And we can again use these sliders. We could change this right-hand tail right here to 10%. And we see that at 415, we have a value where 10% of the profits are above that number. Now, another question is, what is the 90th percentile for profit? And these are calculated if we go in here to the output window and scroll down. We see right here 90%, so that's the 90th percentile. We see that it's basically, at least to a rounding difference, the same as the answer to the previous question. So if 415 is the 90th percentile, that means 10% of values for profit fall above that number. So that's a good example of a simple at-risk model.